everybody. Welcome to the last full-length session in this room today. My name is Mark Smith, and it is my great pleasure to introduce the talk Going Real-Time, Event-Driven Apps with MongoDB Atlas, being given by Kenny Gorman, who's a Principal Product Manager of Streaming at MongoDB. So can we give him a big round of applause, please?
Thanks, Mark. Check, check. Can you hear me? No. Mic, mic. Can you hear me now? There we go. Cool. Thanks, Mark. Yeah, my name is Kenny Gorman. Nice to meet you. Come on in and sit down. We're going to have a good chat about streaming and real-time data in MongoDB Atlas. Just a real brief bio on myself. I'll be brief. I'm normally not. I'm new to MongoDB Inc. I've been here just a couple of months, but I'm not new to Mongo itself. In fact, I use Mongo v 1.0. If anybody use 1.0, 1.2? A few hands. Okay. Well, love you guys. Been there. Awesome time. A journey with Mongo through a number of companies, and I'm really, really excited to be working here now and talking to you about something that maybe you didn't expect, which is streaming data in Atlas. So let's just jump into it. Let's talk a little agenda here. I'm going to do a little intro on what is real-time and streaming, and what do we mean by that. I might move this up here. Is that better? We'll talk some use cases, what is working, what is not, when to use streaming data, what applications work well and what don't. We'll talk about data ingestion in Atlas and some techniques there. And then we'll write a stream processor. We'll talk a little bit about what a stream processor looks like, what you can do in terms of stream processing on Atlas, and I'll show you some tips and tricks. And then I have a cool example. Hopefully you'll like my example. I try to make it kind of fun. And then we'll talk about what's next and where we're thinking about from a roadmap perspective, how we plan to integrate with partners going forward, and what it looks like to do streaming at Mongo. Okay, so let's skip through that. What do we mean by real time? Everybody has a different definition of real time, it sounds like. In our case, we're not going to be talking so much around strict real-time, right? So think of the ABS computer in your car. Very strict real-time application. It's reading a sensor. It's probably using, say, the CAN bus. It's sending an event. It's reading the event at some destination and instantly making a determination if you should brake different wheels of the vehicle to save your life. So that is very, very strict real-time. We're probably not going to be talking about that in this talk. What we really mean by real-time in this talk is what most people would think of as Kafka. Distributed log, events on a bus, pulling those events off and doing something with them. So measured in milliseconds, not seconds, or excuse me, measured in milliseconds and seconds, not just milliseconds or below, okay, microseconds. A little bit lacks sensitivity to latency relative to something like an ABS computer. And that's typically what we mean when we talk about event streaming and event processing and event-driven architectures, okay? So just kind of frame your thinking here. So if you're facing the screen here, you could go way further to the right, and that would be much more like from a batch perspective. And you can go way more to the left, and that's very, very strict in terms of real time. Just to kind of frame your thinking here. All right, so let's talk about some use cases for these real-time event buses. Interestingly, it spans most everything that is happening today with things like IoT, aerospace, fintech, intrusion detection, and network security. Things where you need to know right now that an event happened. So obviously you can't wait for an overnight batch. That's way too long. But maybe you even can't wait minutes. Maybe an indexing strategy on billions of documents isn't going to work for you in this case. You need something more real time. And so that's the kind of things we're going to be talking about here. Had a number of customers in the past that use real-time architectures to do things like monitor a manufacturing facility, like the phone you probably have in your hand is monitored via events. And those events come out and they're built into a dashboard, and that dashboard has alarming and alerting frequencies, capabilities like that. So those kinds of use cases, again, manufacturing, IoT, fraud detection is a very, very common one. So imagine you have an event bus of transactions happening, and when you see fraud measured by some by some query, maybe, then you reach out to a microservice and disable the account. Okay, so that's a fraudulent activity. We're going to disable that account. Happens in real time. If you wait overnight, you've been defrauded. That kind of thing. Okay, so this is kind of framing, hopefully, the use cases we're talking about. All right, so what kind of building blocks does Atlas have for real-time architectures? We mentioned Kafka. Okay, so upper left, we have Kafka here. We have the MongoDB connector for Kafka, if you're not familiar. How many people have used Kafka here? How many people, okay, how many people have Kafka in their architecture overall? Like they use it, they don't use it, but they know it's there. Okay, basically everybody raised their hand here. So that's a lot of people. A very common use case. How many people are using or have used a connector? Okay, not as much. Okay, great. So the MongoDB connector is a great way to connect to Kafka, drain or land that data out of Kafka into Mongo, especially if those payloads in the topic are JSON. It fits right into Mongo, document model, works great, okay? So that's one kind of connectivity option. The other one is the data API, and I'll drill into these in a second, so we can go into more detail. The data API just went GA today, if you see that in the keynote. It's a great way to publish data via IoT sensors and lightweight edge devices into Atlas and then do some processing on them. And in fact, my example uses the data API. I thought it was really cool, so I decided to use it in my example. But inside Atlas, we have the database itself, okay? So the robust, shardable, scalable, fault-tolerant Mongo database with the wonderful document model, okay? So that's kind of a given, we all know that. We have Atlas change streams. So change streams are basically the ability to have a stream of data based on the op log. I'm going to show that. We have Atlas triggers. So I'll deal into that a little bit more. If you're a database professional, you're probably used to the idea of a trigger, but this is a little bit different if you're not familiar. And then we're going to talk about functions. Functions are really powerful and really fun, and I'll dive into that here too. So I'll drill into every one of these building blocks. We'll kind of pull out a couple of things that I think are important and interesting about them, and then we'll build our sample app, okay? So the Mongo connector for Kafka does a couple of things. It is either a source or a sink. So you can take data from Kafka and pull it into Mongo and then run queries on it. Or you can take a change stream out of Mongo and send it to Kafka, like CDC. Okay, so it works both ways. It has really, really cool write strategy customization, so you can set your write strategy according to how you would normally do it, like with an insert. It supports the new time series collection, so that's great. And it's got a dead letter queue capability. So if you're familiar with messages, you'll know sometimes messages don't fit a particular pattern, and you'll want to put them in a dead letter queue, just like an email system, if you're familiar. It's a real powerful paradigm for streaming. So very robust. It's open source, maintained by MongoDB Inc. And it's been out for a long time, and it's quite good. So just to point you in that direction. Now, Data API just went GA. It's been preview for, I think, 8 months, they said. I started using it a couple months ago, fell in love with it. Super easy way to read and write data from Mongo. You go into Atlas, you configure your credentials, and you can just use curl. I think Mark just showed this on screen. Super powerful. And then internal to Atlas, you've got triggers, functions, and change streams. Okay, so let's talk about triggers real quick. You might be thinking like normal database trigger. It doesn't really work that way. An Atlas trigger is the ability to basically generate a change stream. So when something happens on a table or a collection, then that generates a change stream, and you can optionally put the entire contents of the document into the change stream. So now you have a stream of information that was basically the document that was going to go into the database. Now, I'm going to show that in my example, and we'll talk about some of the nuances there. Then functions provide the logic to easily mutate the data. So I had a question earlier today about, can you do selective routing of data? The answer is yes. Can you do mutation or filtering of the data? Yes. Can you aggregate and perform ag framework queries on the data? Yes. And I'll show you a little bit of where that would fit in the code here in a minute. But this is really, really useful. You can bring in data into Atlas. You can turn it into a stream of data. So maybe it goes Kafka to the connector, to a collection, to a change stream, to a function, and then out to something else. Okay? So it's a really, really nice way to pipeline your applet operations. It's fully managed. It's just baked into Atlas. And obviously, all these things are very powerful and flexible. I already talked a little bit about the database. I think, I won't dive too deep into this, but the database is super powerful because it acts like a sink for the output of the streams. So if you're bringing in data via change stream and you need to aggregate that or save it, obviously it's a super easy operation. But then it can also trickle down to things like data lake. It can be used, in any of the tooling systems that we have, like the new Tableau SQL connector they just announced, things like that. So the database is kind of the key and the core to the heart of all those things. All right, so let's talk a little bit about what it looks like to create an example with these things, okay? So what we're gonna do is we're gonna build a cool little sample app, and it's gonna do lightning strike detection. So imagine that I wanna warn my wife if my kids are in the pool and there's lightning near my house. Okay, something like this. So follow me along on this little journey here. And it's on GitHub too, so if you wanna play with it or you wanna do a PR because I missed something, that would be awesome. But come with me on this example here. So what we've got is a weather sensor, and it is just a sensor, an IoT device. It has a REST API, and I'm gonna read that REST API, and I'm gonna bring that data into Atlas and do some stuff with it. And you might say, well, it's not that hard to read one weather sensor. Like, well, there are millions of them. They're all over the place. So, Atlas is important in terms of scalability and durability. If you were gonna make say, a lightning strike detection network service or something like this. For this example, it's just me and my kids. All right, so this is what the architecture looks like for our little sample. It kind of looks like the stuff I showed a few slides ago. So this slide right here, you'll see the building blocks and components that we have in Atlas and kind of outside of Atlas. And then you'll see here how we've wired it all together. So on the left-hand side at the top, we've got a weather event. And then that IoT sensor that I showed is going to read it. And then we've got this Python stream producer, so it's going to handle the REST communication to the sensor. Then it's use the data API and push the data into Atlas, okay? Then we're going to use the Atlas database, a change stream, a trigger, and Atlas functions to process that and create a mobile alert. Now that seems like a lot of stuff, right? Like it's a lot of steps. But I'll show you it's pretty easy. Okay, first things first. We're gonna create a new proxy collection. And I call it a proxy collection because we don't really care about the data in here. Notice how it's a capped collection with a pretty small size. So we don't really care about this data. This is actually just the journal we're gonna use to generate a change stream. Okay, so it's a little bit unique use case here. Then we're gonna configure the data API endpoint. So the way you do this is you log into Atlas, you click on the data API. You'll see mine says preview. I did this before it was available GA, but now it's just a normal GA feature. You create an API key, and you use that in your client software. Okay, and this is where you use that. This is your little stream producer. So this is just a couple snippets of Python here. So you'll see we import requests. If you're familiar with Python, you'll know that's a library for fetching URIs. We're going to go ahead and get the data from the IoT device. We're going to append a date stamp to it, okay, because that's when we found it or when we sensed it. We're going to then before we do this, we're going to build a document, a raw data document in the format that we want that's useful to us. And then we're going to write that as opposed to Atlas. Like, there's more code here in the actual client. You can go take a look at it, but not much. It's pretty easy stuff to write this kind of processor stuff. And Atlas Data API is super useful in this regard. So this is Python. I could have used a native driver, right? But in this case, I was already using REST, and so it was really handy to kind of just use REST again. So it felt really nice, and it has a nice aesthetic, and there's not a lot of other things involved. Okay, so that's gonna pull, let me go back. That's going to pull the data from the IoT weather sensor here, and it's going to push it through the data API into Atlas. Okay, so once we get done with this step here, now it's going to be in Atlas. And this is what the document looks like, okay? So I've got a unique key, a station ID, and it's got a name. Then I've got the observations array. So this is a complex document. The document model is important here. And it's got a document that has a timestamp, and it's got a couple of measurements. So the lightning strike count lasts 1 hour, and the lightning strike last distance. And so these are it's got a lot of other stuff. But these are just the two we're going to use in our little app. Okay, and then it's got that date stamp that we talked about. Okay, so that's the core document that's being sent in via this API. Okay, so here's our processor. So in the stack, we've got the data in. The data's landed in this collection that we have a trigger on. It's a cap collection, so there's only a couple of them. But a change stream is now created. And this is the processor for the change stream. So this is just JavaScript. It's super easy and fun to write. It's just like you would write maybe in the shell or something. And it allows us to then say, okay, if this full document exists, I'll explain that full document in a second, and the count is greater than some number, and the distance is less than some number, then I want my kids out of the pool. Like there's lightning coming, okay? So the next step is if that's true, we're gonna go ahead and use the Twilio library and send a message. So interesting thing there is that Twilio, you can include separate libraries. So this is the Node.js Twilio library. We can just go ahead and include that, and now we have that capability built in. So you can extend this framework as far as you need to. That's super flexible, and frankly, it's pretty fun. So then we create a message and we send it, and then what we do is we log it to the database. Okay, so we had what we're doing is we're keeping this updated document by station of the last time we saw a lightning strike. Now you could also log it to you might want to send this out to the data lake and keep it on S3, so you had a journal. It's like maybe you're routing it that way. Or maybe you're just kind of inserting into a big collection and indexing it over time with the time series indexing, right? So there's a couple of options you could do here. You can just kind of write whatever logic you want. In my case, I'm keeping this like state picture of whatever station and whatever distance that lightning strike was at. Okay, pretty simple stuff. So now we're going to wire these things together. Okay, so on the left here, we have a configuration of a trigger. Okay, it's maybe a little hard for you guys to see. But basically what you do is you specify the collection that you want to trigger on. Basically the cluster, the database itself, and the collection, and it'll tell you, okay, I've got a trigger on that. And then you give it a collection name. In my case, I called it inbound. And that's that proxy collection. I don't really care about it. It's capped. I don't really, I'm not going to query it directly. It's just so I can create that change stream. And then on the right-hand side, we're going to create that trigger. And so all you do is define a trigger. You can define your custom logic, and then you can just paste in the code. Now you might say, well, pasting the code kind of sucks. I don't want to do that. I don't just copy paste stuff into web interfaces. So you can also use Git integration. So the way this works is you download and install the Git application. And the Git application connects GitHub and Atlas. And then when you check in code, like to some branch you specify, it'll deploy that piece of code. Okay? So all I got to do is update my code locally, check it in, and boom, it goes out and starts running it. Now you might say like, oh, that's kind of dangerous. I don't want to just deploy code to prod like that. Well, you can use Atlas native tagging for how to escalate things through dev, stage, prod, just like anything else. So lots of functionality there. I think that's all to say about that. A couple things to mention here is that when you use this integration and you actually do the git pull, it actually pulls a tree of the entire model. So you have the function itself, the function call, everything is basically checked out into the file system, and you can edit all of that locally. So trigger configuration, the frequency it fires. And in this case, I also created a global variable and then assigned that to the Twilio creds. So there's a secret, which is the Twilio creds, and then I have a global variable that's assigned to those. That's all done in Atlas. It's super easy, just takes a few steps, and now all the creds for Twilio, you'll notice, let me go back to the code. You'll notice I didn't actually have to paste anything in here in terms of creds. So if you're familiar, there's like the %% variables. It uses that same framework. Okay, so super easy integrated docs are awesome for this. Okay, so now, now I have a fully running stream processor. If the lightning strike is detected within those boundaries, it's going to be looking at an event-by-event basis. So this isn't some sort of batch, just to kind of point this out. As documents come through the stream processor, each one by one, is going to be turned into a document in the change stream. And we're inspecting every one of them. So just to kind of give you a feeling, like this isn't like every one and n, it's not scheduled, it's not that kind of thing. It's looking at every one of those and determining when a condition exists. Now you might say, like, well, what if it starts getting close? How do I write a back-off algorithm or something so it doesn't keep paging? So you would do that somewhere like here. Okay, so you could just say, hey, after I've got a certain number of alarms in the database, maybe you look at this updated collection, then you could turn it off again. So you have full control over your flow, or the logic of your program. One thing I didn't mention here is full document. So you can decide how much of that document in the change stream gets into the change stream. So in this case, I'm taking the entire document, but you don't have to. You can actually pull in just certain events, like wasn't it insert, update, delete, and just like the primary key and things like that. In my case, I'm actually processing this like a stream. So if you're going to use this pattern, you probably would use full document in almost every case, if that makes sense. Okay. So let's talk about going a little bit further. So that was a cute example. Obviously that wasn't sort of a production use case. It was more of just giving you an example of the components and the building blocks. But if you had that, the next step would be maybe pull that into Atlas charts. Okay, so it's pretty easy to create a chart right off the bat. A few clicks and you've got a chart, and you can embed that chart in applications. Or I mentioned data lake. Maybe you're pushing this down to data lake and you're storing that data, the historical data, in S3. Maybe even routing it there conditionally. Okay. Or the new SQL interface. So I could be reporting on this in Tableau. There's geo-coordinates that are coming as part of this full document. Maybe I wanted to do like a heat map. Okay, I could do that in Tableau very easily, right? If you're a Tableau user. So just kind of give you a feeling for the whole Atlas ecosystem. Like there's more components than just the change stream itself. You can start to link together all these components to build a full app. All right, so let's talk a little bit about the future roadmap. So this was a pretty quick demo of what real-time and event-based architectures could look like on Atlas. But I skipped some things you might have noticed, like I didn't do any stateful operations. I didn't run an ag framework on that stream. Right, I didn't do a window operator. I didn't do some of the harder things. So this is an area that we're super, super invested in thinking about. We have a great ecosystem and partner system with Confluent and others. So Kafka is front and center, as I mentioned before, and an important part of this ecosystem going forward. So that's not going to change. But there's still a lot to be done. If you kind of envision a super large bounding box of all the use cases and capabilities one would want to be effective in a streaming context, well, I just showed you a few. Kafka's a piece of it, Atlas is a piece of it, but there's still a lot to be done. And so over the next year or so, we'll be working on these things going forward. You can kind of squint and imagine kind of the use cases. I talked about state. I talked about maybe materializing views of things. There's a lot of things that are coming down the pipe in terms of roadmap items that are going to build on this kind of thing and be complementary to Kafka and Confluent and the other ecosystem partners. So give you a little sneak peek. And that's it. Thank you for your time.
Okay, can we have a quick round of applause for Kenny? Thank you, Kenny.
Just real quick before you do, there's a bunch of links here if you want to, I don't know if you want to take a picture or whatever, but you guys can check this out and play with it yourself. You tell me what you think, how you might use this kind of stuff in your architectures, and give me feedback. We're always listening at Mongo and would love to hear what ideas and real-time event architectures that you guys are building and working with. So thanks. Sorry, I forgot to mention that.
All good. Okay, so we have some time for questions. If you have a question, please. Yeah, we've got somebody over here. If you'd like to stick up your hand, and I'll bring over the microphone.
Thanks for the demo. Two quick questions. How this works with the Confluent version of the Kafka?
Say that again?
How does this work with the Confluent version of the Kafka? Is it
Okay,
Is
good
it the
question.
same? And the second question is, how does it work with the time series collection?
Yeah, good, great, two great questions. So yeah, to work with Confluent Cloud, look, the Kafka connector works directly with Confluent Cloud. Any Kafka Connect string, any seed string, it would work directly with. So we don't, make a distinction whether it's Confluent Cloud or any other cloud provider. The connector just kind of works that way with the Connect string. What was your second part of your question? Time series? Time series? Yeah, it works directly with time series. So, we've been working really hard, and the colleagues here have been working really hard on the connector itself. And time series support is one of the things that I think just came out in terms of the connector. So you can now put things directly in time series collections. Yeah, good question.
A question here. How would it behave in a clustered environment here?
Thank you.
So, would it result in duplicate changes depending upon number of nodes? How do you manage it?
Right. So how does it behave when data comes into the cluster? Right. Good question. Just like any other piece of data, that would be a chain stream, right? So it's replicated across a replica set, just like normal. Would have all the same characteristics of a replica set. All the behaviors would exist as well. Same thing with sharding, right? So chain stream is a chain stream, and I'm just leveraging the chain stream to be, its native structure.
In other words, for a given change, there will be only unique set of messages, not for every node that's being updated.
Say that one more time, I'm sorry.
For a given change, let's say you're adding to a collection or something, even though it could be replicated to a number of nodes, the change stream will have only one message.
Correct.
Okay.
Correct. Yeah.
Thank you.
Great point. Yeah. It would still be a single message. You're not going to get like triplicate messages in the stream. Great point. Yes.
This might be a bad question, but what is the difference between an Atlas trigger and a change stream?
Okay, so good question. So the difference between a trigger and a change stream is largely just nomenclature, right? So the change stream is the underlying structure we're using, the oplog structure essentially, to manage that, essentially distributed log, if you will, just like Kafka, if you will, logically thinking. And the trigger is the thing that says, hey, I want to actually create a change stream on that collection. So the trigger belongs to a collection and says, hey, when I see this event, now I want to put it into the change stream. And that full document's the thing it puts in there, conditionally, depending on if you have it configured that way. Yeah, good question.
Yeah, I have one question. So in the Twilio, you are trying to send a message when the when the lightning is happening, right? So rather than sending a message, is it possible to play some SOS kind of alert?
I think the question is it possible to write it to a database or do something else with it?
Yeah, like some SOS alert kind of audio, if you could play, that will be even.
Oh, I see. Yeah, I mean, you can do whatever, right? Like, that's the cool thing. Just innovate and build whatever you want. I just chose Twilio because it's handy and I had it available and I thought it would be fun. But you can do whatever you want. Like, obviously, event-based alerting, like I mentioned before, like you could reach out to a microservice that did something like shuts off a user account or, I don't know, calls the fire department or whatever it is, right? So there's a ton of different options. It's just up to you to whatever kind of code you're going to write there. Now, obviously in the code there, I made it simple for the presentation. If there was lightning near you, it would it would message you every message, right? That code is not non-perfect. You would get whatever, 1,000 texts or whatever. But it's my wife, so who cares? Like, she'll just have to deal with it. But yeah, I mean, so it's kind of, the logic's up to you, how you might want to back off, how you might want to archive, how you might want to route it. I just kind of showed the most basic possible example so I could kind of show you the code. So, good point.
I think we've got time for one more question. So, you were the first person I saw.
And thanks for the great demo. The question is related to when we are the change stream listener, right? So if I have multiple change stream listeners, can all those listening to the same events or unique? They listen to unique events.
Yeah, was the core of your question about how many change streams can I have and does it scale kind of thing?
Yeah.
Yeah, right. So I think a couple things there. One is, right, so there's only a certain number of chain streams. I actually don't know the answer to how many, what the number, what n is. But yeah, you could easily bog down a system by creating too many too many listeners essentially on a particular stream of events. That said, I did say that this is an area of work for us, and we're going to continue to. Change streams is, we eat our own dog food here in the sense that change streams powers search, right? So, and a lot of other things too, right? So, and including a couple announcements today. So it's a core component to our system, and it's something that we're investing in building in. So it's only going to get better and better and better. It works great today up to a pretty high workload, but it will be even better tomorrow. So that's kind of the roadmap for that. A great question.
I think we've run out of time for questions, but Kenny is going to be out in the hallway afterwards if you want to have a conversation or ask any more questions. Don't forget to rate the talk. And if we could just have one more round of applause for Kenny, please.
Thank you.